So we can put a trace show in right here to take a look at the shell after we've modified the environment. And welcome back to episode 6 of Haskell from Scratch. And I've received the question a couple times now of how far I intend to go with this series. And I intend to take it all the way to the end until we have a working implementation of redo that we can compare against the other implementations out there. So however many episodes it's going to take, as long as the recordings stay interesting for you guys, I'm going to keep recording them. In the last episode, we refactored some of the code, specifically the code in monadic do blocks, and we also changed this command function here to use unwords. And I mentioned that you kind of had to take it on faith that this is working correctly until I show you the Debug.Trace module, so we'll take a look at that right now. So if you import Debug.Trace, there is a function called trace that it exports. And the type of trace is, let's actually take a look at it in GHCI. So it takes a string and then any value and returns that value. And the reason it has this type is that it allows us to print out the string anywhere in code, in pure code included, and then return the value that's given as the second argument. So in this case, if we want to look at the result of this unwords, we could do it here. We could trace, we can give an argument, and then it's going to return back the result of this unwords here. There's only one unfortunate part of using this, is that sometimes you have to repeat what you're trying to look at to look at it here. So let's compile this. And then on the second run, we should see it. So to get rid of this little annoying problem, let's go ahead and make our own version of trace. We'll call it trace prime. And I'm not going to give it a type signature. I'm just going to repeat this argument here so that we don't have to. So trace prime here. And run it one more time to make sure it works. And great. So now we can see the result of any value we want anywhere in the program. Let's go ahead and take a look at, just to give you another example, let's take a look at this exit here. And we get some errors. And this first error here is saying that exit code is not of type string or a list of characters. So one thing we could do is show that. So we can change our trace to show the argument instead of just assuming it's a string. And so now on the second run, we get the command and we get the exit code. Trace, since this is a common case, trace also exports a function called trace show. So we can change our code to use that. So trace show arg. And just to get the names to match up, let's call ours trace show prime. And test it one more time. There we go. So that's enough with tracing for now. It's time to go add another feature to our program. And up until this point, we've been using redo to just rebuild everything, regardless of any files have changed. And what we want to do is, similarly with make, we want to know what the prerequisites or dependencies of a target are, and then only rebuild the target when the dependencies or prerequisites have changed. So the way this looks in redo, in our redo file, we would have redo-ifchange, and then we would give the dependencies here, redo.hs. Now redo is a little bit interesting in contrast to make, for example, in that this isn't a special directive that we're parsing or anything like that. Redo-ifchange is just going to be a program that collects and records this dependency information. And the way it does that is that on the first run of redo inside of a project, no dependency information is known yet. So the redo, the .do script will be run, and this redo-ifchange will be called, and at that point it will record the dependency information. Since we have to build everything one time anyway, this actually works out. And once redo-ifchange has recorded the dependency information, on the second run we'll have that information available to us to cut down on any work we don't need to do. So the question for us at this point is, how do we implement this? Let's assume that we have a redo-ifchange program, and I'm just going to make it a shell script right now so we can mock it out. So it's going to be receiving some arguments here that is, let's say, the dependencies of this. But what it's not receiving is the target that we're rebuilding. So we need to communicate to this redo-ifchange somehow what the current target is so that it knows where to record this information, these dependencies. And rather than look at how any of the other implementations handle this, I don't want to be biased by their decisions. We can go ahead and check how they do things for compatibility purposes, but for purely implementation purposes, I'd like for us to make all the decisions from scratch. So one way that jumped to mind was passing along an environment variable so that you'd have something like redo target available to the script that is set before the do file is run. And that way, if we have recursive builds that we're doing, or we're recalling redo recursively, which is how it's designed to run, we can just keep updating that environment variable. So let's go ahead and go into the code and see how we can do this. One way is to use a command like environment, which you can see the details of here. And we could set the redo target environment variable with this, but aside from the possible incompatibilities between FreeBSD and Linux, we also don't want to be too tied to having to have certain commands installed, especially if we ever want to get this working on Windows, for instance. And so while I know that we're already using shell here and assuming that there is a Bourne shell, which is something we may be able to eliminate in the future as well, let's see if there's a way we can do this without invoking an external command. And we should also get the benefit that it runs a little bit more quickly than spawning another process. So one way to do this is through the import system.process and take a look at create process. There is an environment member that is maybe a list of string pairs. And that list of string pairs is keys and values. So what we can do is, here's a way to update a record. Remember that shell is giving us back a create process record. And then we can use this syntax here to update just one member of the record. So we'll say we want just redo target and set that to the target. So let's compile that. And env is not a visible constructor field name. Let's go ahead and bring in all of create process and its constructor fields and compile again. And so now when we run this the next time, we get a strange error. And the error is that GHC is not found. So you might have already guessed at what's happening here, but let's investigate just in case you didn't know. And we're going to print out all of the environment variables here at the beginning of the script. So we're not seeing anything, and what's happening here is, if you remember, standard output by default is being captured here by this redirect to the temporary file. So we're not going to see anything on the console unless we redirect it to standard error. So this is saying take standard output and send it to standard error. And so now when we run this, we see that environment is returning two variables, pwd, the working directory, and redo target. And what you're not seeing is all of these others, including, most importantly, the path. And without that path, the script doesn't know where to find GHC. So instead of this just these here for an environment, it turns out we're actually overwriting the environment in that case. And what we want to do is sort of append this to the environment. So there is a function for this in system.environment called getEnvironment. And that gives us back a list of pairs, just like we are setting in the create process. So if we just take a look at the type, we're getting a list of pairs. So we can say, okay, the old environment here, get environment, and we're going to append our redo target to that, or prepend it. So let's try this again. But the problem is that we've gotten our redo into a state where it's not working. So let's just rebuild this manually for now. And get environment is not in scope. Try that one more time. Oops, we need to get some parentheses around this. Okay, so now we should be able to run redo. Great. Let's take a look at the environment again. But this time, instead of printing it out from inside of the do script, let's use trace show to take a look at it. So we can put a trace show in right here to take a look at the shell after we've modified the environment. So let's recompile. And we have this error that there's no show instance for create process. So we'll need to create a show instance for create process. But we want to be able to derive an instance, and normally you derive an instance when you are defining it, or defining the data type. So if you had data create process, and then you were put in all the fields here, and you'd say deriving show. But we didn't define create process, so it would seem that we couldn't derive show. But GHC actually provides an extension for this that allows us to type deriving instance show create process. And when we try to build this, GHC tells us the extension we need to enable. And since I think this is the first time we've used a GHC or a language extension in this series, I'm just going to show you. You could either add it here, standalone deriving, and we get an error which we'll look at in a second, or what I think is a little bit nicer in this case is to put it in the file itself as a language annotation and a comment, not strange, standalone deriving, strange deriving. Okay, so now let's take a look at what this error is. And it says that there is no show instance for standard stream, which is presumably part of this create process record. So let's try standard stream. And standard stream is not in scope. So let's bring it into scope. Notice that, let's see here. I misspelled stream. And it says that the data constructors are not all in scope, so we need to bring those in as well. And we have another error that looks kind of familiar. So this is for command spec. So let's try command spec. Do the same deriving trick here for command spec. And try this one more time. And now finally, we get to see the create process record. And now you can see that redo target is here in the environment, as well as the path and everything else. Now, the only problem I can anticipate with this is what happens if redo target is already set here. For example, let's say I'm appending home to this. And you can see here that home is in two places. What'll actually happen? And as far as I can tell from the documentation for create process, there's really no behavior defined for this case. So to be on the safe side, what we should do is insert or replace the redo target variable in case we're being called in a recursive context where redo target will already be defined. So one way to do this, and I'm just going to move it on to another line so that it'll be a little bit easier to see, is we can take this redo target and prepend it to a list where we've filtered out any existing redo target pair. So in case you haven't looked at or used filter before, it takes a predicate in a list and returns a new list of all of the elements that match that predicate or are true for that predicate. So for example, if we wanted to find every element in a list that was equal to 1, that's how we would write it. Or if we wanted to filter out all of the ones, we could say, filter for anything that's not equal to 1. And in the case of a list of pairs, like we have here, say we want to compare only on the first element of that pair, we could say, okay, this is A, B. We don't need the second one right there. So let's say we only want pairs that don't begin with a 1. And that would be one way of writing it. Or if you wanted to write this a little bit more compactly or point free, you could use the first function, which takes the first element of a pair, and write it this way. So we're saying not equals to 1 of the first element of the pair. So using that, we can filter out for anything that's not equal to redo target of the first element of that pair on the old environment. And here we're just going to have the new environment. So let's give that a try. Let's compile this. And just to test that it's working properly, let's just change this to home. And we should only have one home at the beginning of this list and no home anywhere else. So that seems like that works. Let's put this back to redo target. But to be sure that everything is working, we want to print this out inside of the redo-ifchange program. And again, we're going to need to redirect things to standard error. But redo-ifchange is not being found because it's not in the path. And we could fix this by changing our do script like this. So let's give that a try. We need to make redo-ifchange executable. Try that one more time. So you can see that this is working properly now. We see redo and redo.hs here, which is our redo target and then the arguments to this redo-ifchange program. But I don't want to have these in here, this current path, because we might be in a subdirectory and then things would break. So let's go back to the code. Since we're already modifying the environment, we might as well modify the path while we're at it so that redo-ifchange works. And to do that, we're going to need to change just the pair that is the path environment variable. And doing that with just normal list operations gets a little bit tricky, but what we can do instead is use a map. So let's take a look at that. I'm going to use data.map.lazy, which at the time I'm recording this is the preferred way to use it. And we'll be using a function insert, which does what we're doing right now with the redo target insertion. We're also going to need to be able to convert from a list and to a list, like we have with the environment. So let's quickly take a look at this in GHCI. Import data.map.lazy, and then just look at the type of from list, for example. And it takes a list of pairs like we have and returns a map. And toList is going to do the opposite. So instead of using this filter here, what we can write instead is first we're going to convert the old environment to a map. So we're going to use from list. Then we're going to do an insert. We're going to take the new key and the value, and then we're going to convert this back to a list. So let's make sure this compiles, and it's working. And if you look now, notice that redo target is no longer at the head of this list. It's somewhere in the list based on however maps organize the results on toList. So we can get rid of this other line of code, and now we have a place we can just add another operation into this pipeline to modify the path environment variable. So we'll use the function adjust, I think it's called, and adjust takes a function to adjust the value at a given key, which will be path. So for now, just to test this out, let's go ahead and append the current working directory, and let's try that out. So after we've compiled it and run it once, now if you take a look at the path, notice that there is a dot at the end of it, and that redo-ifchange has been found and run. Now, I said earlier we don't want this to be just the current working directory, but for now, just for the sake of time, we're going to leave it as it is. And in fact, I think this is a good time to wrap up the episode. Even though we're leaving the program in a sort of a messy state, we just got done last episode cleaning it up, and now we've made a bit of a mess in the pursuit of adding a new feature. We have debugging output on the console, we have these traces and these other list manipulations in here, and the program's not in a working state, but I'm going to go ahead and commit the changes and tag them in the GitHub repository so that you can follow along until the next episode, where we're going to keep working with this and hopefully get the feature to the point where we can actually record these dependencies and then make use of them so that we're not rebuilding things we don't need to rebuild. I've noticed, for myself at least, while doing development, that this sort of expansion and contraction, these cycles of expansion, implementing a new feature, and then contraction, trying to keep the code clean and understandable, repeating over and over again, is how I tend to develop software. And it sort of feels like the tension on a rubber band, where as I'm implementing a new feature, I'm stretching and pulling the rubber band, and there's a lot of tension, and I can feel as I'm writing the code, that things are starting to get a little bit out of hand and a little bit chaotic. And then there's finally this point at which the feature is implemented and working, and I can begin to release a little bit of that tension, let the rubber band contract again to this sort of resting point. And the rubber band's bigger at this point, and it gets bigger every time it gets stretched out, just as the code continues to get bigger and bigger as more and more features are added. But instead of just one giant stretch trying to add all features at one time, and probably breaking the rubber band in the process, if you let me stretch the analogy that far, we're kind of going through these cycles where we're pulling and releasing, adding more code and then bringing it down to a manageable size, and then adding more again and coming back. And we're going to go through these cycles at least a few more times before we get to the end of this implementation. As always, I appreciate any feedback you have on the episode. I read through all the comments on the last one about recommendations for refactoring and making the code look cleaner. I haven't put any of them into action yet, although I might with some of them in the future. Right now I'm just focusing on getting these new features added. But if there's anything you notice, anything you want to mention, leave a comment. I'm sure it's not just useful for me, but for other people who are watching as well. So I hope you enjoyed it. Again, thanks for watching, and I'll see you next time.